Hello everyone, welcome to Neha's Maths Academy. In this video, we are going to learn some examples on counting principles. Our first example is, how many ways are there to roll two distinct dice to yield a sum evenly divisible by 3? The total there are 6 into 6, that is 36 outcomes after rolling two distinct dice, because for one die there are 6 outcomes. So for two dice there will be 6 into 6, that is 36 outcomes. So to yield a sum which is evenly divisible by 3, the possibilities of sum on the two dice should be 3 or 6 or 9 or 12. So the possibilities are 1 2, that is 1 on the first die and 2 on the second die, or 1 5, 1 on the first die, 5 on the second die. Similarly, these are the possibilities for obtaining 3 or 6 or 9 or 12 as sum on two dice. So there are 12 ways to roll two distinct dice to yield a sum evenly divisible by 3. Next example. How many 6-letter words with repetition are there in which the first and last letters are vowels, in which vowels appear only as the first and last letters? This is the second example. There are 5 vowels in the alphabets: A, E, I, O, U, that you know. These are the 5 vowels. So there are 5 ways to choose vowels in the first and last positions of the 6-letter words with repetition. These are the 6 positions of 6-letter words. In the first place, there are 5 ways to choose, and for last place also, there are 5 ways to choose vowels. Now for remaining 4 places, there are 26 ways because repetition is allowed in the first case. So if repetition is allowed, for each of these 4 places, we have 26 choices. So by multiplication principle, there will be 5 square and 26 into 26 into 26 4 times. So 26 raised to 4, 6-letter words with repetition in which the first and last letters are vowels. Now in the second, for the remaining 4 places, there are 21 ways for the second case in which vowels appear only as the first and last letter. Means vowels can't be appear in middle places. So there will be 5 choices for first and last place, but there are only 21 choices for middle places. So by the multiplication principle, there are 21 raised to 4 into 5 square, 6-letter words with repetition in which only the first and last letters are vowel. Our next example is, how many different 6-digit numbers are there? So here we can use all the 10 digits, 0 to 9. Total there are 10 digits, 0 to 9. So for each place, there are 10 choices except first place, since 0 can't be placed at the first place. So as you can see here, there are 9 choices for the first place because we can't place 0 at the first place. And for remaining 5 places, there are 10 choices. So by the multiplication principle, there are 9 into 10 into 10 into 10 into 10 different 6-digit numbers. Second part is, how many different even 6-digit numbers are there? As we want even number, there are 5 choices for the last digit. There can be only 0, 2, 4, 6 or 8 at the last place for the number to be even. So there are 9 choices for the first place and 5 choices for the last place, and in the remaining places there are 10 choices. So by the multiplication principle, there are 9 into 10 into 10 into 10 into 10 into 5 different even 6-digit numbers. Our next part is how many different 6-digit numbers are there with exactly 1 3. So there will be two cases. First digit is 3 or first digit is not 3. So if first digit is 3, there is only one way to choose 3 as the first digit. And in the remaining digits, we can place in the 9 ways because we can't place 3 in the remaining places. So there are only 9 ways for remaining digits, and for first digit, we have only one way to place 3. So by the multiplication principle, total number of ways will be 1 into 9 into 9 into 9 into 9 into 9. Our second case is first digit is not 3. So if first digit is not 3, we can't place 0 and 3 at the first place. So there will be 8 choices for the first place and only one choice to place 3 in either of the 5 places. So suppose here 3 is in the second place. So one way to place 3 at the second place, and for the remaining places we can't place 3. So there are 9 choices for each of the 4 places. So by the multiplication principle, there are 5 into 8 into 9 into 9 into 9 into 9 ways. Now how 5? Because there will be, means 3 can be placed in either of the 5 places. So there will be 5 ways. By adding all the above cases, our total number of 6-digit numbers with exactly 1 3 is 9 raised to 5 plus 5 into 8 into 9 raised to 4. Our next example is how many sequences of length 5 can be formed using the digits 0 to 9 with the property that exactly 2 of the 10 digits appear. We want exactly 2 of the 10 digits, means either 1 5 or 2 7. Any two numbers can be appear in that length 5 sequence. So firstly, choose these 2 digits. We can choose 2 digits from 10 digits by C10 two ways. That is 10 choose 2. So for each place in the sequence, there are 2 choices. There are 2 choices for each of the place. By the multiplication principle, there are 2 raised to 5 ways. So 2 into 2 into 2 into 2, 5 times. But exactly one number can also appear in all the places of the sequence. For example, 3 is appearing in all the 5 places, or it can be 2, 2, 2, 5 times. And we want to avoid this case because our property is in that sequence there should be exactly 2 digits. So we have to subtract this case. So there will be 2 cases as there are 2 numbers. So subtract 2 from 2 raised to 5. So total number of ways will be C10 2 into 2 raised to 5 minus 2 for length 5 sequence with exactly 2 different digits.